Alright guys, welcome to this page of the notes, and what we're going to do here on this page is take a look at sort of the first new factoring technique. We're really going to kind of get introduced here in this section of the chapter 5. And what we're doing again is we're looking for ways to factor polynomials. We're trying to figure out methods that we can use to find the zeros of a polynomial. And one of those methods we could use, one of those tools that we could use, is what's known as group and factor. So here's the way it's going to work. I know you can see it there, but let me highlight it for you. We're going to use the associative property to group terms that can be manipulated to produce a common factor, a GCF, that I can pull out. Let me show you exactly how this is going to work. I take a look at this polynomial that I've been given. It actually is a 4-term polynomial. And I take a look at it, and I'm looking at these guys, and what I recognize is that there is no GCF. 3, 4, 6, and 8. The greatest common factor that those constants have in common is a 1. But pulling out a 1 doesn't do me any good whatsoever, so I don't have a GCF for the constants. I have an x to the third, x squared, x, no x, which means I can't even pull a variable out of all of them. So these 4 terms together, the way they're written together, I don't have a GCF. So what we're going to use is this neat little trick, this method known as group and factor, to group together terms that do have a GCF, so that I can then pull that GCF out of just that grouping. Let me show you how this method works. What I'm going to do is I recognize just by looking at it that, hey, if I group these first 2 terms together and these last 2 terms together, now these first 2 guys do have a GCF I can pull out, as well as the last 2 terms have a different GCF that I can pull out of them. Okay, so let's go ahead and do that. I recognize that 3x to the third and 4x squared, I can pull an x squared out of both of those terms. So I'll pull an x squared out, and what's left then would be a 3x. When I pull an x squared out of a negative 4x squared, I'm left with a minus 4. Okay, so what I've done is I grouped the first 2 terms together because those guys have a GCF. I pull that GCF out, and this is what's left over. Okay, great. My next 2 terms, which I've now grouped together, okay, I recognize that they have a GCF, right? I can pull a 2 out of both of those. Plus 2. When I pull out that 2, 6 divided by 2 would be 3x. And a negative 8 divided by 2 would be a minus 4. Now, here's sort of the catch to this particular method. This method, group and factor method for factoring, only works. It only works as long as after you have pulled out your GCFs, right? This was my GCF for the first ones. And this was my GCF for the second grouping. Once I pull out those GCFs, what's left in the parentheses must be the same. It has to be the same. If it's not the same, if I don't have the same quantity left over in both of my groupings, then the method did not work. And either group and factor is not going to work at all. It's just you need to pick something else to factor, or you just simply grouped your terms together incorrectly. Go back and try a different grouping. Notice I grouped the first 2 and the last 2 together. I certainly could have grouped the first and the third, so put 3x cubed and 6x together in parentheses, and put the negative 4x squared and the negative 8 together in parentheses, and try that one, right? So there is a little bit of trial and error here, but again, the point is this. This method, group and factor, only works as long as the quantities that are a result of pulling out a GCF, they must be the same. Have to be completely identical. If they're not, then group and factor didn't work. So I get 2 quantities that are absolutely the same, And so here's your final answer. You take your GCFs and you make them a quantity. So x squared plus 2 is one of my factors, right? And then the 3x minus 4, right, because those are the same, that becomes my second quantity, 3x minus 4. And so guys, here's what's going to happen. If I were to FOIL these two factors, it would get me right back to what I started with, right? So I have now used the group and factor method to successfully factor this polynomial, which initially had no GCF, but using the group and factor method, I was able to group together terms that did have a GCF and work my way down to this as my factor. So there you go. We'll practice this a few more times on a couple other problems. So let's try another one. We'll go through this one a little quicker. This one's got way more terms in it. Again, though, here's the idea. You're going to want to group together terms that you recognize definitely are going to have a GCF. Please notice I have x, 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 y, y, y. A good bet is that you're going to want to group together those terms. So I'm going to group together 8ax plus 4bx plus 4cx. Put those guys together. I'll group together the y's, 6ay plus 3by plus 3cy. And again, now that I've got my groupings, and I don't know that this is going to be the way to go. There's many combinations here, but it's probably pretty likely this is going to work. I go through and pull out my GCF. Well, 8, 4, and 4 all have a 4 in common, so I'll pull out a 4. And all the terms have an x in them, which is why I group them together. So let's pull that out. 4x, and what I'm left with then would be a 2a plus b plus c, right? That's what's, I pull out a 4x, I'm left with a b, I pull out a 4x, I'm left with just a c, 8 divided by 4 would be 2, and I'm left with the a. On the other side, 6, 3, and 3, well, I can pull a 3 out of all of those constants, and everybody's got a y, so pull out a 3y. That's going to leave me with a 2a. Hey, look at that. So far, so good. I had a 2a here. I need a 2a here, and I've got it. Pull out a 3y. That leaves me with just a b. Awesome. And leaves me with just a c. Fantastic. So here's what I've got. I pulled out my GCFs, 4x and 3y. And what's left over? The quantities left over are identical. So the method worked. It was successful. And I can write my final answer. Remember, the GCFs are written together as a quantity, and then the quantities that were left over after doing pulling out your GCF become your second quantity, 2a plus b plus c. And again, guys, the point is this: if you were to use the distributive property to multiply all that stuff out, you would get right back to what you had originally been given. I got a few more of these we can try. So we jump to the next page of the notes, and again, I take a look at this, and all of them together, right, there is no GCF. There's nothing I can pull out of all of them. But if I were to group some of them together, I think we'll quickly see that I do have a GCF that I can pull out of some of them. So here we go. I've got, let's see, an FY, FZ. I've got a GY, a GZ, an HY, and HZ. It looks like what I'm probably going to do here then is group together, oh, you know what? Y, Z, Z. Yeah, okay, so we're going to group together Y's and Z's. So 20 FY plus 15 GY minus 10 HY takes care of that one, and that one. And then I group together all the ones that have a Z in them. Okay, so that's going to be minus 16 FZ plus 8HZ minus 12GZ. And that groups together all the ones that have a z, which takes care of that one, and that one. All right, so I've taken care of all of my terms. I now have them grouped together based on just sort of initial glance at it, recognizing what some of them have in common. So now I'll go through and pull out what I can. 20, 15, and 10. Looks like I can pull out a 2, and of course I can pull a y out of everybody. That's how I knew I was going to group those ones together. So we'll pull out a 2y. That's going to leave me with 10f. Sorry, hold up. Nope. I cannot pull a 2 out of 15. How about we pull a 5 out of all of those? Let's go 5y. Leaves me with a 4f, a 3g, and a minus 2y. Better. Okay, and then the next one. Let's see. Well, obviously I can pull a z out of everybody. That's why I grouped them together. But a negative 16, an 8, and a minus 12. Let's pull out 4, right? I can pull out, let's pull out a negative 4. So I'm going to pull a negative 4 out of all of those. Minus 4z. And let's see what that gets me. A negative 16 divided by a negative 4, well, that's going to leave me with a 4f. Perfect, awesome, 4f. Let's see, 8 divided by 4. Oh, you know what? Actually, here, let me sorry, I wrote a y. I pulled the y out. Oh, good thing I caught that. I'm taking a look at this and like, wait, what's going on? Sorry, that should be, I pulled a y out, which means the y goes away. I should be left with an h. And so now here's what I'm going to do. Since I've got a g here, right? I've got the g written last and the h written in the middle. I'm just going to have those guys switch places so that g comes next and then h. It's not that big a deal. So instead here, what I'm going to do then is a negative 12 divided by a negative 4 would of course be a positive 3. So plus 3g, which is exactly what I was given here. Then I'll do the h. So 8 divided by a negative 4 would be a minus 2, and then of course the h, so minus 2h. Now I've got these guys in the correct order so that my quantities are exactly the same. So GCF worked. Write my factors, 5y minus 4z, by taking my two GCFs and putting them together, and then since these guys are the same, they're my second quantity. Okay, and I apologize, sorry about that little mistake I made right there. I brought the y down instead of the h, but we got it all put together, and again, if you were to distribute these guys together, multiply it all out, you get right back to what you started with. Got another one here for you. Let's see what this one works out to. All right, so I'm taking a look at all these guys, and again, it looks pretty obvious to me. I'm going to want to group together the x's and group together the y squareds in this case. That's interesting. All right, so I grouped those guys together, and then I grouped together minus 5ay squared plus 4by squared minus cy squared. And here we go. I'm going to pull out an x, and then let's see here. I have a 30, a 24, and a 6, which I believe I can pull a 6 out of all of those. So we'll do 6x, which is going to leave me with 5a minus 4b plus a c. And then the next one, I'm going to pull out, let's see, I got a 5, a 4, and a, okay, so the only thing I can pull out is a -1, right? A -1 is all, my minus 5, my positive 4, and my -1, right? They only have a -1 in common. So I'll pull that -1 out, and then of course the y squareds. So I'll pull out a minus y squared, and when I do that, that leaves me with a 5a minus 4b plus c, which is exactly, now both of those are exactly the same. So I write my GCFs as my first quantity, which is a 6x minus y squared, and then 5a minus 4b plus c as my second quantity. Again, if you were to distribute all that out, multiply it all out, you get right back to what you started with. All right, I got one more for you here. I'm taking a look at this guy and looking for a GCF, which there is no GCF for all of these guys together. So we're going to go ahead and separate them up into factors. AX, BZ, BY, AZ, BX, AY. Okay, so it looks like I'm going to want to do maybe A's and B's. Yeah, we're going to do A's and B's. So 13 AX plus 9AY minus 14AZ. Okay, so that takes care of everybody that's got an A in it. Then my Z's, nope, then my B's. Okay, so it's going to be minus 32BX minus 15BY plus 18BZ. That takes care of everybody that has a B in it. Now again, the reason I did this grouping is because I recognize A. I know I can at least pull that out. B. I know that I can at least pull all of that stuff out. So here we go. 13, 9, and 14. Whew. I don't think there's anything other than a 1 that I could pull out of each of those. Yep, so it looks like in this case, all I can do is pull out an A. So I will. I'll pull out an A. That's going to leave me with 13x plus 9y minus 14z. Kind of ugly, but we'll see. 32, 15, and 18. 32, 15, and 18. I can pull a 3 out of 15 and 18, but I can't pull a 3 out of 32. I can't pull... Okay, so these guys, there is no GCF for those constants other than a -1 or something like that. I could pull a -1 out, but that doesn't get me these constants. So it looks like that didn't work out. So we're going to scratch that, which absolutely can happen. And let's try again. So what if instead I group together, right? I've got X and X, Y and Y, Z and Z. Let's try that. 13 AX minus 32BX. And then I'm going to have 9 AY minus 15BY. And then I'm going to have minus 14AZ plus 18BZ. Okay, so here we go. Now I've grouped together the X's, the Y's, and the Z's. Let's try pulling that stuff out. 13 and a minus 32. Once again, it doesn't look like I have a GCF I can pull out of those guys other than a -1. So all I could do is pull out an X, which leaves me with a 13A minus 32B, which is kind of ugly. 9 and 15, I can pull out a 3. So I'll pull out a 3Y, which leaves me with 3A minus 5B. And okay, already I recognize I'm in trouble. These two quantities are not the same. And guys, this problem actually serves as a great example of something that you'll find can happen. If you try a couple of times and it's not working out, it is totally possible that group and factor does not work. These don't have a GCF no matter how you were to group them. And we simply write this guy is 5. So if group and factor does not work, then the polynomial is what we call